When somebody says nuclear power, your first thought is probably going to be Chernobyl, Fukushima Daiichi, or even Three Mile Island, all examples of why nuclear power is dangerous and why we shouldn't use it. But in actuality, nuclear power is one of the safest and most reliable forms of energy we have today. So, how does it work? Nuclear physics can be complicated, but the basics of nuclear energy generation are relatively simple. Current nuclear reactors work on the basis of nuclear fission chain reactions. Nuclear fission occurs when the atoms of reactive material, like uranium or plutonium, split into two or more smaller nuclei. Then, each of these nuclei knock into other atoms and cause them to split into nuclei, which again causes more atoms to split and knock until we have a nuclear fission chain reaction. You can think of the chain reaction like a game of pool. After the initial hit with the cue ball, the billiard balls continue hitting other balls, just as the new atoms keep reacting. So how do we turn this into energy? The basic elements of a nuclear reactor are the reactor core, the turbines, the control rods, and the cooling systems. The nuclear fission chain reaction occurs in the reactor core, which is filled with water, which generates heat in order to boil that water into steam. The steam from the boiling water then turns the turbine in order to generate the electricity that we use. A control rod is a large part of the regulatory systems. It's typically made of cadmium or boron, and it regulates the chain reaction by the materials as they absorb neutrons, meaning that when they're inserted into the core, they slow the fission reaction by absorbing the particles involved in it. Those iconic towers we associate with nuclear reactors are actually cooling towers. They vent out steam to help cool down the reactor system, along with water that is continuously cycled through the reactor core. Because we want to generate heat in order to generate electricity, but too much heat will cause the reactor to fail. So we use the cooling systems and the control rods to regulate the amount of heat that the reactor produces in order to prevent a meltdown. In the case of a nuclear accident, the term meltdown is literal. The reactor melts down due to the excessive heat generated by the mass amount of chain reactions. Which begs the question, why did those past accidents occur? Chernobyl can be blamed on the design of the reactor itself and the unsafe testing conditions, where an undertrained crew was forced to restart the reactor with very limited cooling systems. And Fukushima was caused by the 2011 tsunami and earthquake. But even including these accidents that are genuine tragedies, coal power kills more people every year than nuclear power has over the span of its existence. Nuclear power was initially developed as a weapon. Reactors were designed to create the materials to make atomic bombs, and that has been the driving force behind nuclear reactor creation for decades. However, today we are facing an energy generation crisis, and nuclear energy is a safe, reliable, and low-carbon form of energy generation that continues to improve. Atomic weapons don't have a place in our world, but we shouldn't vilify nuclear power as a whole because of them.